All right, this is chapter 1, section 1, points, lines, and planes. First thing we're going to talk about is a point. A point is a single dot. It's the simplest figure in geometry. It's named by a capital letter, and all geometric figures consist of points, okay? We've got 2 points. We've got A and B here. Let me draw a third point, and I'm going to label it lowercase c to show you that this is not allowed, okay? Every single point must be a capital letter. You can label it capital D. You can label it capital C, but it must be a capital letter, okay? Second thing that I want you to know is that points are non-dimensional, so they have no dimension, okay? In other words, they have no size, all right? Next thing we're going to learn is a line. A line is a geometric figure consisting of at least 2 points. It's extending in 2 directions without end. It's named by 2 points or a single lowercase letter, okay? Cannot be a capitalized letter if you're going to use one letter to define the line. And it goes through any 2 points. There is exactly one line. There's not more than one. There's just one line, okay? So you'll see points A and B. And there's a line called line L that goes through them. You can label it line AB with a line on top with 2 arrowheads on each side, and line lowercase l. Okay. You could also reverse this and you could label it line BA. Okay. However you would like to label it. Now lines are different than points. They actually have 1 dimension. Okay. They are 1-dimensional. And moving on, next thing, we've got a plane. A plane is a geometric plane is suggested by a floor, wall, or tabletop. So it's a flat surface. No thickness. Okay? Planes also continue on without end, and it has no thickness, okay? Although it has no edges, it is shown like the figure below. So we cannot physically draw something that doesn't end. So we have to give our planes edges like this one has, but technically there are no edges to a plane, okay? It's a flat surface that continues on forever. And it's named by a single capital letter or 3 or more points inside the plane. So this can be plane M. We're gonna label 3 points in here. We're gonna label A, B, and C. Notice how all 3 of my points are capital letters. And we can also call this plane A, B, C. All right, space, collinear, and coplanar. A space is a set of all points. Collinear means that points that lie on one line. Non-collinear, they're not on the same line. Coplanar means that points, they lie on the same plane, coplanar. And non-coplanar are points that are not on the same plane, okay? All right, let's think about it. How many lines can be drawn through exactly 1 point? If you have 1 point, you can draw as many lines as you want through that point, facing in different directions. So the answer is infinitely many. How many lines can be drawn through 2 points? If there's ever 2 points, there's exactly 1 line that goes through them, so just 1. How many planes can be drawn through 1 point? Okay, so if there's a single point, there's a plane here. You can also adjust the angle of that plane. There's another plane here. There's infinitely many planes that can go through a single point. Okay, because you can adjust the angle of the plane, you can tilt it, you can rotate it, however you want to do it, but there's infinitely many planes that go through a singular point. How many planes can be drawn through 2 points? Well, 2 points create a line, and a line also can be contained in infinitely many planes. Okay, and how many planes can be drawn through exactly 3 points, okay, that are not on the same line? So if they're non-collinear, that is exactly 1 plane, okay? Because then that's the definition of a plane. We define a plane by 3 non-collinear points, and there's no other plane that will contain those 3 points, okay? So exactly 1. All right, segments. A line segment is just a piece of a line, okay? So it actually has 2 endpoints A and B, and all the points A and B that are between A and B are contained in your segment, okay? So if we have A as one endpoint, B as another, your segment becomes the area or the section in between them that is between A and B, okay? We also notice there are no arrowheads when we're labeling a segment because they don't continue on forever. Segments have a measure. Next, let's talk about array. A ray is written as the ray AB, okay? Make sure your notation, it must have an endpoint over the A, and it must have an arrowhead over the B, okay? That means that it starts at A and it continues on forever going in the B direction. This one would correspond to the first image that you see. The second image, which is BA, like this, notice how the arrowhead is going over the A because it's continuing on in the A direction, and its endpoint is at B, okay? So it starts at B and it continues on forever in the A direction, okay? You can write it as ray BA, or you can write it as BA with an arrowhead over the A. All right, opposite rays. Opposite rays are very specific rays. They must face in opposite directions, and they must share an endpoint, okay? So the two opposite rays here would be CA and CB because their endpoint that's shared is C, and they're facing in opposite directions. One's going in the A direction, one's going in the B direction. I'm going to draw a negative or a bad example of opposite rays. Okay? These two, although they share the same endpoint right here, they are not facing in opposite directions, okay? Opposite directions, an opposite ray to this one would be this one because it's completely opposite, okay? So this is an example of something that is not an opposite ray. Okay, intersections. Intersect means to meet or to cut through. Intersection of two figures is a set of points that are in both figures. Dashes in a diagram indicate the parts hidden from view. Okay, so this is an example of two planes that are intersecting. Their intersection becomes this line, which is line K. Okay, also when two lines intersect, for example, line PQ and line K, they intersect at the point. This is point M. All right, now let's go ahead and do some examples. State whether it's true or false. Line PF, there's a random line PF, it ends at point P. Well, a line continues on forever by definition, so this has to be false. Okay? Point S is on an infinite number of lines. Yes, if you have a singular point, there's an infinite number of lines that go through it. This one's true. A plane has no thickness. This one's true. That's part of the definition of a plane. Collinear points are coplanar. This one's also true. If they can fit on a line, they can fit on a plane. Planes have edges. This is false, okay? Although we draw the edges of a plane in a diagram, technically they have no edges because it continues on forever. Two planes intersect in a line segment. This is false. Why is it false? Because when two planes intersect, they're actually intersecting at a line, not a line segment, okay? Because the planes technically never end, so therefore the line that they intersect at is never going to end. Two intersecting lines meet in exactly 1 point. Two intersecting lines meet in exactly 1 point. This is true. And points have no size. This is true. Okay, points are non-dimensional. They have no size. Line XY can be denoted as XY or YX. That is also true. Okay? The order when you're defining a line, not a ray, it doesn't matter. And when you're defining a segment, same thing goes. The order does not matter. Okay, example 2. Use the diagram to classify whether it's true or false. Is the point P in the plane M? Okay? Is P in M? And this is false. Okay? The reason is because P is located in the plane N, okay, but it is not a part of the plane M, okay? B is in M. Is the line B, I know it's a line because it's a lowercase letter. I know it's a line because it's a lowercase letter, so it must be line B. Is this one in plane M? That is correct, so that is true, okay? The plane here contains this line. Line XY contains P. Well, XY is this line. This is true. This is our line, XY. If it's a line, it's going to continue on forever. Does it contain this point P? That would be false, okay? M, the plane, contains XY. This one's true. That line XY lies in the plane M. A is on B. Is the point A on the line B? That is true. This line B passes through the point A. A and P are in M. This is false. Point A is in plane M, but point P is not in plane M. This is very similar to number 1 as well, okay? Number 7, N contains the point P. This one's true because point P is in the plane N. All right, these are all the notes. Go ahead and turn these in.